Hey all, it's Andrew Catch here, and this Tuesday video, I'm going to be going over forecasting with profit. So I've made a few videos on forecasting, and I wasn't very happy about the types of content I created through it, just because oftentimes I couldn't find a good data set for it, and also it really didn't represent what I think is modern forecasting. So in my previous forecasting videos with like I think Model Time or Fable, I was mostly going like over ARIMAs or ARMA models. But now, since I've done a decent amount of forecasting, I actually don't do these traditional ARIMA forecasting models. Instead, I actually use Profit. In fact, I kind of recommend that we should basically always be using Profit, unless if you have some specific thing that you want to really work on. But I figured I'd go over Profit and also using kind of the TidyModels infrastructure or framework around it. So I figured this would be kind of a short, quick video going over, how simple it is to use Profit to forecast data. So I'm going to open up a R Markdown document. I'll say Tidy Tuesday Profit. Okay. And I am actually using their data set from Profit. So let me load that in. And it's called example retail sales. Okay. So this data set, I believe, doesn't have any other exogenous variables. So I think we're just obviously predicting some type of retail sales. There's a date column, which is called DS, and a Y column, or a column where we're trying to predict, I'm assuming like their monthly retail sales. One package that I actually like using when I'm doing forecasting is loading in the Lubridate package. And this comes with like some nice helper date functions. So right now, I'm just going to create a little tester, and I'm going to create a as date, right? And let's see if that actually do it. She doesn't. So we can just do month, day, and year, right? As dot date. Right, so month. Yeah, there you go. Cool. So we have our date. And I'm gonna say cleaned df. And let's actually do some plots. So just do a simple line chart. And we can see we have a nice little trend with our sales. Obviously, we can see like some type of monthly component or some type of seasonal component. But overall, our average monthly sales is also increasing. And that's actually something we kind of see a lot when we're doing some forecasting. So I think when people want to do some type of forecasting problem, is generally with like some type of sales or products um, or views and stuff like that. And generally, that type of stuff that we're trying to forecast is actually going to be moving or non-stationary. And that's actually kind of a problem with things like ARIMAs, where we kind of have an assumption that it's non-stationary, or where the average value or the average is not changing. If I add like a, I don't know, like a, smooth, and just do that, we can see that obviously, the average with the linear model is saying that this trend is increasing through time. So that can be a problem if we're trying to forecast this type of stuff. Luckily, with Profit, we don't actually have to have an assumption of stationary or non-stationary data. It's kind of baked into it. In fact, we actually can change our specific methods for how we want to assess the trend. But let's actually go in and see what we would want to do when we're approaching like a time series problem. So one of the things that we can think about when we're looking at our clean DF is if we did a basic split. So if I want to do like a wrong split, so wrong split, and say initial, initial. Oh, oops, did I not get TidyModels? Oh, I forgot to do TidyModels. Okay. Jeez. Okay. So if I do an initial split and we do our cleaned df, if we look at our actual train and test data, so if we do a training long split, uh, wrong split, right? And then we can say like type is equal to train, and we'll just kind of do that. And I'm gonna basically combine these splits with the respective train and test sets. So we're gonna do that. Test, cool. And we're gonna make the same plot. Right, we can see that this actually isn't good for our the types of data that we're working with. So, generally we want to have randomly sampled data sets so we don't have any problems. We can have a good representative, features for our models. But when we're dealing with these time series problems, we can't split it in the traditional way. We always have to think of a time component, and that's where we really need to think about is like data leakage. So if I created like a generic linear model, I'm sure it would really quickly overfit because we have some data leakage where we can have access to future data while also trying to predict something less in the future. So luckily, TidyModels kind of is aware of this. So we actually have a initial time splits. So instead of doing that, uh, was it clean df? Right, we'll do the same thing. So we'll say correct splits, and then we'll just do that. So this is the correct way to split your data because it's kind of taking, if we say arrange by DS, we can see that now it's doing what we would want it to do, where we're training a model with data with data that's not in the test data set for that time period. So that way we don't have any data leakage. And one thing that I kind of would want to say is that, just because you're not doing a direct forecasting problem, just because you're not forecasting, a univariate time series where it's just like some type of sales, it's still useful to think about when you're assessing your features. So when I'm creating some models, I generally will look at these features that I'm using, such as like age, stuff like that, and say, is there like a time component that I'm missing out on that's causing leakage? So it's good to kind of think about that. So oftentimes you actually might be using like an initial time split that doesn't have directly like a date component that you want to use. So that's always a good thing to use. But let's actually go with profit, where we can actually do a few different things. So right now, what I want to do is just show everyone, what does profit look like? What's the workflow for it? So generally, when you're creating a forecast, you want to give it the data set. So we're going to give it a clean df. Assume it's arranged in the correct order from date. And what's interesting about like forecast is that you're generally always refitting it to basically predict the next period. So right now we have this data set. And if we do it, so this is like from 2016. So for like January, what is it? In the next few months, we'd be refitting it once we observed more data, because that's how it kind of understands how to forecast the next period. So what's kind of useful about profit is once we have our model, we actually use that model to create what we want to forecast. So in this case, we're going to use the make future data frame. And this is essentially the periods that we want to forecast in the future. So we pass it the model, which is M, our periods. And with the periods, we can say like, hey, maybe we want to forecast like 6 months out. We have to also just specify our period. So obviously right here, they have day, week, month, quarter, year. But you can also go in like seconds, minutes, hours. In this case, we want to do month. And lastly, we have include history. I'm just going to include the history right now. And what we call this usually is the future. And then you can make your forecast by just using the simple predict. So M and future because you're using your model and your, essentially your data set that you want to predict on. And we usually call that forecast. So if we look at our forecast, you can see we actually have a lot of stuff. We have our time, our trend, our additive trends, our yearly components, stuff like that. And then we also have our lower and upper bound, and then our actual prediction. It's actually nice if we have like plot, what is it called? A profit plot components, and then forecast. So if we do that profit plot components, we can see we have our trend components, so we can see what's driving our trend. We can see like our deseasonalized stuff. You can also, I think, just plot out M and forecast, right? And then right here we can see that it's fitting. It's fitting the model, and it's also showing what it was seeing from the past data sets or past observations. So we can see that it fits it pretty well. And this is what we're trying to forecast right over here. And yeah, it makes sense. It looks nice. This data set is extremely like seasonal, and it's pretty consistent with the seasonality. So this is a perfect data set for our model to run on. One thing that we also want to look at, so not only do we want to look at like our components right here that we're forecasting, but we also can add our change points to the plot. And this is basically saying like when we're creating our models or our forecasts, where is it seeing a change in the trend? And that can help diagnose things where, hey, maybe our model is picking up something weird that we don't want to. Maybe we should do some regularization and change that, or reduce the amount of change points. Or hey, we can see that there's a change point, and that's actually making a lot of sense. Where else do we see a change point that maybe the model's not picking up? So right here, Prophet again is pretty useful since it kind of can automatically detects it, which requires basically little to no tuning at all. But what's also nice about Prophet is that we can actually specify specific change points in the future. So if we're expecting, some crazy monthly or marketing campaign for a product, we can basically say like, hey, model, this thing, the thing that we're trying to forecast right now, it's gonna have a change and probably hopefully an increase in like say like product sales. So for like this, we could say like we're gonna run a crazy Black Friday sale, and we're gonna push all of our salespeople. We're gonna increase huge commissions on it, so they should be pushing out a lot of the product. We can actually anticipate that and put that into the model pretty quickly. So let's actually go over how would we like tune a model if we kind of want to start doing that. So first, we can see our actual components right here. We have like our change points, our end dot change points, and stuff like that. In general, you can change your scale. So you can change your, let me do a change point. So there's 3 things we really want to change. Change point prior scale, I'll just say 10. Seasonality prior scale, which I'll say 10, and holidays prior scale. There are a few other components too. So in case we want to add in our seasonality mode, we can have an additive or multiplicative. In this case, we actually might want to consider changing it, right? Because the trend's a little bit different. But in general, the 3 points you want to add in are your change point prior scale, seasonality prior scale, and holiday prior scale. And how I remember it is it's always like a prior scale. And then seasonality mode is something where you kind of want to look at the data set and change it yourself. You can also do the change points. So change points is change points is like a vector of dates. So that is where you would basically be inputting future trend changes that you're going to anticipate. So like if you're doing some type of huge change in like a business, that's where you would be putting it into. So again, that's pretty easy to do. But let's actually go over, say, how we would change our models, or just kind of say like how would we assess our models in a machine learning framework. So when we're looking at our data set right here, we can see that we have our train and test set. But one of the things we want to think about is like, well, what if we want to try multiple parameters, right? And it doesn't seem the best way to do it if we want to just assess it on this data set or on this test set right here. It'd be nice to be able to have, multiple, folds to tune a model and assess its performance. Luckily, we actually have that with the TidyModels, and it's called rolling origin. And with rolling origin, we have our data, our initial, and our assess. The default is cumulative, but what it's basically saying is we can have essentially a kind of a cumulative data set. So in this case, if we can say like we want to take this from 2005 and older, we'll use that data set, and then we'll also predict it for the next year. So I'm just gonna go do this right now. So we'll say initial, we'll say give it a year, and assess, we'll give it 6 months. And if I do a train, a map splits and analysis, test equals map splits assessment. And I'll do a pivot longer, just so I can show you guys what it looks like. Okay, let's see what that looks like, and then I can do maybe I'll do and then I'll say filter. Let me count the ID first. Okay, so then I'll say filter. Filter ID is in slice 001, slice 002, slice 003. Right, cool. Cool. And now you can see kind of an example of this where it's essentially rolling it. It's saying like, our first data set will have 52 samples, and then we'll increase it and we'll assess the next six periods. So right there, you can see how it's changing, stuff like that. Again, if we count our IDs, we can see that it's increasing by 1. So it's saying like we're gonna have these 58 or 52 58 samples that we're trying to predict on, or train and predict on, and then we'll go up by 1 more increment, and we'll have 59. We'll go up 1 more at 60, and it'll go on and go on and go on. So as you see, that's pretty useful for what we're doing. So we essentially have that many. There also are different ways to do it. So instead of just having rolling origin, where it's doing it by 1 period, we can also do a sliding period. Oops, sliding period. In this case, we can kind of have it by obviously a period. So if we want to do, say, like so sliding period, our index is our essentially what we're going to be sorting or kind of being basing our period on. And then we could say our period, which could be I think let me say, we'll say like year, and our look back. Oops, look back can be like infinity, and our assess like stop can be, I don't know, like 1, right? So now we have like, I don't know, we have a different way to sample it. In that case, it's more by a year than by index. But you can see that there's different ways to skin a cat for it, and there's also sliding index, which is more about like the numbers and stuff like that. So if you want to specify a certain amount, but again, nothing too interesting. Maybe I can show you guys train data. It goes map splits training, or it's analysis, and then test data, assessments. Do another thing right there. Filter ID is in C slice 01, slice 02, slice 03. a nest. And we'll do the same plots. All right, so you can see it's going by a year. So yeah, again, this might be a lot of stuff, but the functions are pretty self-explanatory. I think the trick that I learned from it is using look back as an infinity. But let's actually go over training a model and then going over some model metrics for our thing. So in this case, I'll probably just do this thing right here, just because it's like 24. So I'll say like a time. I'll say time series k folds, right? So now that we have our time series k folds, we can tune two models. So I'll just create a helper function, say tune profit function splits, and we'll just do the same thing. So train data can be like analysis splits, test data equals assessment splits, and then our profit model will be that df equals train data, and that'll be like our M1, and our trend will be seasonality will be additive. Okay, so we have that model. And then we can do M2, which would be how do you spell it? Which is seasonality mode multiplicative. Cool. And then we can do a future. Make future data frame M1 periods is equal to n row test data. Freak is week. And then we'll say include history equals false. And then we can do our predictions. So predict M1 future. And what I always do is just select the DS and Y hat or the date and the prediction. And we'll do it with the other model. Right. In this case, we can do a few different ways to do it. I'll just make this more of like a tidy way. So I'll say type is equal to additive, and that type is multiplicative, and we'll just bind the rows and put that in. And lastly, we'll left join our test data by its by the date. Cool. And obviously there are different ways to do this. So we could create a generic tuner function. So like tune profit like 2 functions splits, and then we'll say like season type, right? And then we can just do that and switch out with the M to seasonality mode to season type. And then we'll just do like, I don't know, do that, and then do that. So right here, again, different ways to do it. But you can see that, you know, both ways can do the same thing. However, I'm kind of more hard coding it just because, you know, I know what seasonality or what parameters I want to tune. But again, you can just do it this way and it's cleaner. But it depends on, like, I guess the how you want to do it. But we'll probably just do tune profit because it seems like the easiest thing to do. And we'll use our time series came fold. So say time series, I'll say TS tune. Map the a function or map the splits to tune profit. And we can get the results right there. And we'll wait. We'll get some different seasonalities coming in. Okay, should be, hopefully it'll be done soon. Another thing that we could have done is basically added in a progress bar. But let's see, your time series K full, it's 24, yeah. But yeah, we got everything. Cool. So you're gonna get some of these errors where it's like the seasonality is different. You can say like suppress messages or suppress warnings, and prevent those from coming out. So I just say select ID and res, unnes res. Ooh, oops, left join. Uh-oh. Assessment splits. Let's see here. Assessment. Ooh, did I let's see here. Look, splits. One. Analysis. Okay, and then we'll do this one too, where we'll do assessment. 1993, yeah, that makes sense. So we have anyone 93. Date 1992. Okay. About 2. Yeah, 24, 1992 to 1993. Okay, what's going on here? So it's saying predict M select DS Y hat, mutate type, test data. Let's see here. Tune profit. That's a little odd. All right. Time series K folds is clean DF. DSY hat arranged by DS. Period is year. Look back to infinity. Okay. Okay. I'll just do a bind columns. Okay. Let's do this again. I'll just do that. In profit, and we'll do it one more time. In fact, actually, I'll do a slice tail n equals 10. Yep. TS tune. And then we have, what is going on here? Oh, it's not lining up. Okay. That's interesting. Okay. Let's see here. Test data is that. Oh, freak is week. It's a month. That's why. Okay. That's just a little typo because I usually do with use weekly data. And I totally forgot that this is not weekly. So we can do that. Frick month. Do it again. Sorry about that, but this is kind of a good video to highlight. Just some more live coding and find out where I was making the errors and stuff like that. So, okay, cool. So now we have our data set. One thing I actually do like doing is I like grouping by ID and the type or the parameters, arranging by the date, and also creating like a forecast field. This is assessing like how far out our forecast is. The forecast is equal to row number, right? So after that, we can use our forecast type DS, Y hat, and Y. And there are different ways that we can assess this. So one thing we can do is just do a group by forecast type. And then we can do a, RMSE, truth equals y, estimate equals y hat. And we can assess that through saying like, group by forecast, slice min estimate, right? And kind of count that. We can see that our multiplicative has less error. But another thing that I like to do is at the end of the day, I like to try to beat a specific baseline. So in this case, when we're doing this, with forecasting, it's generally nice to have a baseline. In like classification, it's saying like, if you predict the class with the highest frequencies. So the baseline for that is actually like naive forecasts. So with a naive forecast, you're just predicting the previous period. So we can actually do that pretty simply by going to, let's see here, clean DF. I'll just create a naive right there. So mutate naive equals lag y n equals 1 order by yes, drop that name, select yes and naive. So this is a weekly naive or a monthly naive forecast. So we'll just do a left join by equals yes. Yeah, it's right there. So this is essentially what we can do, and we can use what's called the mean absolute scaled error, which is the mean absolute error for your forecast divided by the mean absolute error of a naive forecast. I like to do it this way just because we have a little bit more control over saying what counts as a naive forecast. So there are different ways to do it. For me right now, I'm just doing a simple, naive forecast where you assume that you can just predict the previous month's data. But if we're predicting, 6 months out, you don't actually have, say, if I want to predict in December, I don't have November's data. So, how you can say like what is our lagged or what's the naive value that we're going to use to forecast can just depend on what you're going to do. So in this case, we're just going to do the most conservative amount, where we're basically going to give our naive forecast the most power, where essentially the naive forecast is kind of doing some data peaking. But there's also ways where we can do like some other things where like we can say we can do like a group by the ID and stuff like that, and select the most recent month as a naive value. But we'll just do it like this. So forecast type summarize MAE mean absolute y hat minus y by mean absolute naive minus y. So right now we're calculating the mean absolute scaled error, and we can see that maybe we do a pivot slider, names from type values from equals MASE, and just do like a comparison plot or something. So x equals say additive, y equals multiplicative, GM ab line, or like a little y equals mx plus b line, GM point, and then a chord is observed versus spread. So we can see, where our forecasts are doing well at and stuff like that. Cool. So let's do that. Mean absolute scaled error. And for this case, I'll just do like maybe a group by type and get the like median mean absolute scaled error. So I'll say median equals median MSC, and we can see our multiplicative has a slight edge on that, and that kind of makes sense. Again, we can also do another way to do the how we assess a naive forecast. So instead of this, we'll just do an ID, right? And we'll say, oops. So right here, we can say like, we'll group by our ID and our ID and our type, and we'll say our date is like DS equals, we'll say our joined or our naive date, is our min ds, right, minus month 1, right? So if we go right here, it's arranged by ID and DS. We oh, yeah, we can see like, so this is the month that we saw, but our naive date is this. So this will join basically our naive forecast values onto, oops, oh, onto our naive date. So you can just do that right here. And instead of joining it by DS, we'll say naive DS is equal to DS. Oops. We got ungroup. Oh, that's why. Okay, so that way we have like a more realistic naive value, and then we can do the same thing what we did right here. So we can just do a group by forecast, right? And we can get, you know, some more forecasts, right? And that makes sense because now our mean absolute scale there has improved a little bit better than our naive, because we're using a different threshold for the forecast. Okay. So let's actually look at our final models and see how it compares. So we'll make a little profit model. Actually, I got an idea. I'll go back up here and we'll grab the profit. Right. So this is our original forecast, and this is the one that we found that had a slightly better performance. So we'll say a multiplicative. Right. So we can see it's adding a little bit more change points, but it looks like it's fitting a little bit nicer. So yeah. That was basically it for this video. I know, you know, we had some problems with the joining and understanding, you know, the frequency of the periods, but this is a pretty straightforward way of how to do most time series forecasting problems. You will get, you know, some more complexities with like adding, you know, exogenous variables, looking at, you know, specific holiday effects and stuff like that. But we're just like assessing a basic forecast. I think Prophet has a lot of cool and useful tools, and we can also utilize TidyModels to deal with some of these more fancier resampling methods for time series components. So it's pretty good to have at least some of these stuff in your arsenal, regardless if you do a lot of forecasting or not. With that being said, I'll see you guys next time, and tidy on.